This video will continue to explore some of the ways RETScreen can be used to analyze the energy impacts of various decisions and projects related to a wide range of transportation modes. I'll look at archetypes for marine transportation and aircraft in this video, starting with the former. The Virtual Energy Analyzer lists archetypes for maximizing efficiency and optimizing supply for marine transportation. I'll select the archetype Pre-Swirl Stator. The location of this project is not especially important because the cargo ship which this archetype pertains to will not have a fixed location. After the archetype is loaded, on the Facility worksheet we see an image of a pre-swirl stator. As the ship moves forward, fixed vanes in the stator upstream of the propeller impart to the flow of the water a swirling motion, thus improving the propeller efficiency. In the Notes section at the bottom of the Include Measure table on the Energy worksheet, we see a brief description of the archetype, including an estimate that the fuel consumption can be reduced by up to 5% with this technology. Clicking on Cargo Vessel shows the energy-related inputs for the base case and proposed case in this archetype. The archetype assumes a fairly large vessel operating on diesel fuel. The price of diesel is 70 Canadian cents per litre. As with all inputs, that could be adjusted if necessary. The annual fuel consumption is calculated based on the number of hours per year that the vessel is traveling, as opposed to the distance it travels. The archetype suggests that in both the base case and the proposed case, the vessel will be underway for 6,500 hours per year, which is about 3/4 of the total number of hours in a year. During that time, the vessel consumes 2,092 litres per hour in the base case and 2,020 litres per hour in the proposed case. That corresponds to a reduction of about 3.4%. If we had no idea of what to use for the fuel consumption per hour, we could consult the table in RETScreen's help. The number of units, set to 1, refers to the number of ships that the pre-swirl stator is being used on. The annual fuel consumption, in both litres of diesel and kilowatt hours of fuel energy, is shown for both the base case and the proposed case. At right, the savings, which is the difference between the two, is provided. The savings column confirms that this is a 3.4% decrease and results in annual fuel savings of $328,000 per year. The pre-swirl stator adds $400,000 to initial costs, but leads to no increase in operation and maintenance costs over the base case. The Include Measure table summarizes the benefits, savings, and costs. The fuel saved is, in units of kilowatt hours, almost 5 million annually, resulting in the annual fuel cost savings of $327,600 per year. This is nearly equal to the incremental initial costs of the stator, so the simple payback period is only slightly longer than a year. The finance page confirms that this is a very attractive project. Turning to air travel, I'll again use the Virtual Energy Analyzer to let RETScreen's archetypes get us started. Let's examine how providing preconditioned air to an airplane stopped at the gate can save fuel and reduce GHG emissions. In this situation, fresh, temperature-controlled air is provided to the airplane using grid-powered air conditioning units located at the gate. This allows the aircraft to shut down all its engines and its auxiliary power unit, at least one of which would need to operate if the plane were to provide its own air conditioning. Here, location is indeed important, since the GHG emission factor for the grid will have an impact on the overall emissions reductions. After loading the archetype, the Energy worksheet shows two elements. The airplane itself has a slightly higher fuel efficiency, since less fuel is consumed while the aircraft is on the ground. The savings of 1.4% amount to over $87,000 in fuel cost savings. To model the energy required to precondition air for the plane, this other system has been added. Notice that the base case contains zeros, since there is no preconditioning in the base case. In the proposed case, the electricity required for the preconditioning system is entered. The details about how this value is obtained, as well as interesting cost information, are in the Notes section. The comparison page on the Energy worksheet breaks down this information in various ways. We can see that the fuel savings are over 130,000 litres annually, And as usual, RETScreen's other worksheets are filled with the information we need for this pre-feasibility analysis. The emissions worksheet shows that the GHG emissions reduction is over 340 tons annually, and the finance worksheet shows that not only is this a great financial opportunity when available, but that it is very cost effective in reducing GHG emissions, costing negative $287 or, alternatively, saving $287 per ton of CO2 equivalent removed. RETScreen's transportation archetypes allow us to explore the feasibility of many different types of transportation projects related to marine transportation, aircraft, trains, off and on-road vehicles.